Today we are going to discuss about luminescence spectra. So before going into detail, let us examine what is luminescence. It is the emission of light by a substance. It occurs when an electron returns to the electronic ground state from an excited state and loses its excess energy as a photon. So actually here the transition is between different electronic energy levels and it is an emission spectra. Luminescence spectroscopy is a collective name given to three related spectroscopic techniques. They are the molecular fluorescence spectroscopy, phosphorescence spectroscopy, and chemiluminescence spectroscopy. Now we are going to discuss all these in detail. Now we can explain this fluorescence and phosphorescence with the help of a diagram which is called the Jablonski diagram, and the diagram is named after the Polish physicist Alexander Jablonski. In this diagram, you can see that a total of 6 processes are here, and the first 3 are given in blue color, the other 3 are given in red color. And the processes given in blue color are they involve photon, and the other 3 are radiationless transitions. So here you can see as ground electronic state and 2 excited electronic states, and each electronic state contains a large number of vibrational energy levels. And the excited state, one is singlet excited state and the other is triplet excited state. And if the electronic spins are parallel and antiparallel, we call it as singlet excited or singlet state. And if the electronic spins are parallel to each other, we call it as a triplet state. So here, by the absorption of radiation or by the transition occurs from a ground electronic state to any of the excited electronic levels, and that is a process involving photons. Now come to number 4, that is the vibrational relaxation. What do you mean by vibrational relaxation? It's a non-radiative transition. That means this non-radiative transition can occur through different mechanisms, and one of them is vibrational relaxation. Vibrational relaxation, it is the relaxation of the excited state to its lowest vibrational level, and that is by the dissipation of energy to the surroundings of the molecule, and that is a radiationless or non-radiative transition. And here you can see that that can happen occur in electronic state as well as in excited states. That is the transition is from excited vibration level to any of the lowest lower vibrational levels. Then next one is intersystem crossing. Intersystem crossing means it is a transition between different states or states between having different multiplicity. Here we can see that the transition is from a excited singlet state to excited triplet state. That means there is a difference in the multiplicity. So that is also a radiationless transition, and that is called the intersystem crossing. Next one is internal conversion. So when vibrational state of an electronically excited state can couple to a another state of lower electronic state. That means here the transition is between states having same multiplicity. That is given by number 6, and it is called internal conversion. It is also a non-radiative transition. And the other 2 important transitions are fluorescence and phosphorescence. That is very important. That's given by number 2 and number 3. If the transition is from an excited singlet state to the ground electronic state, we call it as fluorescence. And if it is from an excited triplet state to the ground state, we call it as phosphorescence. Both these are radiation or they are processes involving photons. So that is Jablonski diagram. So the luminescence spectra, in luminescence spectra, not only these 2 processes, one more is there, that is chemiluminescence spectra or chemiluminescence. What do you mean by chemiluminescence? It is again the electronic transition that occurs during a chemical process. So as already said, the luminescence spectroscopy is a collective name of all these 3 phenomena. Thank you.